This is Algebra 2, spring test number 1. We got through lesson 6.3, where we're adding, subtracting, and multiplying polynomials. Number 1, simplifying the difference of these. Negative 7x minus 5x to the fourth plus 5 minus a negative 7x to the fourth minus 5 minus 9x. Remember, start with the largest degree, the biggest exponent. In this case, it's the fourth power. Negative 5x to the fourth minus negative 7x to the fourth minus a negative. Remember what that means? That means plus a positive. So negative 5 plus 7 is positive 2x to the fourth. We're adding and subtracting bases, so we're not adding exponents. All you do is put the coefficients together, 5 minus a negative 7. The next biggest degree is x to the first power. So right here we have negative 7x. Again, it's minus negative 9x. Minus a negative means plus a positive. Negative 7 plus 9 is plus 2x. Then you have a constant term, negative 5, again, minus a negative 5. Negative 5 minus a negative 5 means negative 5 plus 5, which gives you 0. So that's going to be plus 0. There's no reason to write plus 0. So this is the simplified answer. You can't put 2x to the fourth added together with 2x to the first power because they're not like terms. 5w squared minus 8w minus 7 minus 8w squared plus 6w minus 2. 5w squared minus, okay, another way to do these problems, anytime you have minus in the middle, is to change the sign of everything after it. So instead of positive 8w, negative 8w squared. Instead of positive 6w, negative 6w. And instead of negative 2, minus a negative would make it plus 2. The rest of it would look just like it is. 5w squared minus 8w minus 7. And then combine all the like terms. The biggest degree is w squared, 5w squared, and negative 8w squared. When you put those two together, you get negative 3w squared. The next biggest degree is w to the first power, negative 8w and negative 6w. Putting those two together, they're the same sign, so add them up. 8 and 6 is 14, and keep the common negative 14w. And then the last one is negative 7 plus 2, positive 2. Opposite sign, subtract them. 7 and 2 is 5, and 7 is the higher absolute value. It's negative, so keep the larger sign, negative 5. Again, we can't put these together because they're not like terms. Negative 3w squared minus 14w minus 5. This is simplifying the sum, so now you're just adding it, so it's just keeping all the same signs. The biggest degree, again, 7u to the third plus 2u to the third. 7 plus 2 is 9u to the third. The next biggest degree is 3u squared minus, there is no other 3u, there's no other u squared. Notice there isn't one in the polynomial on the right. So it's just positive 3u squared, just like it's written. The next biggest degree is u to the first power. Notice there is no u to the first power in the polynomial on the left. So it's simply negative 8u. Remember, if that had been minus before that set of parentheses, you would have to switch the sign there. So it would be plus 8u, but in this case, it's not. Then the last thing is the constant terms. 7 plus 8 is positive 15. Remember, you can only add and subtract like terms. Like terms means they have the same variable. In this case, they're all u, but it has to be with the same exponent. Simplifying the product, you have to distribute 2 and n because it's one term. 2n times n squared is 2. Now we're multiplying the bases, n and n, they're the same. When you multiply bases, you add exponents, 1 plus 2. 2n times 3n is, 2 times 3 is 6, n to the 1 plus 1. And 2n times 4 is plus 2 times 4 is 8n. When we put those n's together, we have 2n to the third plus 6n squared plus 8n. Now we're adding the same bases, so we do not add the exponents. That's only when you multiply the same bases. And you have 2n cubed plus 6n squared plus 8n. The same thing for this one, 3p to the fourth times 4p to the fourth. 3 times 4 is 12p to the fourth plus 4 is p to the eighth. 3p to the fourth times 7p to the third. 3 times 4 is positive 21. I'm sorry, 3 times 7 is positive 21. P to the fourth times p to the third is p to the seventh. 3p to the fourth times 4p. 3 times 4 is 12. P to the fourth times p to the first. You add p to the 4 plus 1 is p to the fifth. And 3p to the fourth times 1 is plus 3p to the fourth. Again, at this point, you can't combine any of them because they're not like terms, because all you're doing is adding them instead of multiplying them. Same thing, 5x to the seventh times 8x to the seventh plus 3y to the second. 5x to the seventh, multiply 5x to the seventh times 8x to the seventh, multiply 5 and 8 to get 40x, and add the exponents 7 and 7 to get 14. Also multiply 5x to the seventh times 3y squared. 5 times 3 is plus 15. But in this case, you don't have the same basis. One's x and one is y. So you cannot add 7 and 2. It's simply x to the seventh y squared. For this next one, you're going to distribute again 5a squared times this is 15a to the 2 plus 4 is 6. And 5a squared, 5 times 3 again is plus 15. But again, at this point, just like number 6, I left off number 7. Just like number 6, a and b are not the same basis. So it'll simply be a squared b. Number 9, 8p times negative 3p squared plus 6p minus 2. So 8p times negative 3p squared. 8 times negative 3 is negative 24. P times p squared, you add them. 1 plus 2 is p to the third. 8p times 6p. 8 times 6 is 48. P times p, you add them again, is p squared. And 8p times negative 2 is negative 16p. Went back and added in number 7. 6a to the 7th times 6a to the 4th minus 8b to the 6th. 6a to the 7th times 6a to the 4th. You multiply 6 and 6 to get 36. A to the 7th times a to the 4th. You add the exponents, a to the 11th. And 6a to the 7th times negative 8b to the 4th. 6 times, you multiply 6 and negative 8 to get negative 48. But again, you can't add the exponents a to the 7th and b to the 6th because they're different. A to the 7th, b to the 6th is all we can do with this one for number 7. Number 10, simplifying negative 8.7 to the 0, anything to the 0 power is 1. Negative 2 to the negative 4th power. Anytime you have a negative exponent, ride the elevator. Remember, if there's no fraction present, you can create a fraction by putting something over 1. If you ride the elevator, anything raised to a negative exponent needs to go down. If it's at the top, it goes down. So now it's going to be at the bottom of the fraction, negative 2, and it'll be raised to a positive value instead of a negative value 4 this time. You can't leave nothing at the top, though, because if you do, 0 divided by anything will simply make it 0. So just a placeholder in this sense would be 1. So we need to finish this problem up. It'll be 1 over 2 times itself 4 times. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 1 over 16 is your simplified answer for 11. For number 12, 12 over a to the negative 7th, b to the ninth. Nothing's manipulating 12. There's nothing adding, subtracting, multiplying, and dividing, or as far as nothing goes, nothing that we know. We don't know a's value. We don't know b's value. What we do know is that something can't be raised to a negative exponent like it is, in this case, a to the 7th. Anytime something's raised to a negative exponent, just like on number 11, it has to ride the elevator. In this case, unlike on number 11, it's at the bottom of the fraction. So we'll just simply bring it up to the top of the fraction. 12 is not being raised to a negative exponent, so 12 will stay on the top where it is. B to the ninth is not being raised to a negative exponent. It'll stay on the bottom just like it is. But when a to the 7th goes up, it becomes a to the positive 7th. So 12a to the 7th, b to the ninth. For number 13, we're multiplying the same basis. 3 times 3 times 3. All of them are the same. So add the exponents. 3 to the negative 3 plus 5 plus 5. Negative 3 plus 5 is 2, and 2 plus 5 is 3 to the 7th power. Number 14 is 4.48 to the negative 7th times 4.48 to the positive 7th. Those are the exact same bases. Notice they're both 4.48 multiplying by each other, which means you add the exponents. 4.48 to the negative 7 plus 7. Negative 7 plus 7 is 0, and we know anything to the 0 power is 1. X to the negative third times 4x to the positive 6. If you need to, you can write in a 1 here to know you multiply 1 times 4 and get 4. 1 times 1 to get 4. And you multiply in the same basis, x and x. So you add negative 3 plus 6, which gives you 4x to the positive 3. For number 16, you have negative 2g to the 8th times 5h to the 10th times 6g. Multiply negative 2 times 5 times 6. When you multiply negative 2 times 5, you get negative 10, and negative 10 times 6, you get negative 60. And then multiply your bases. You have two of them that are g to the 8th and g to the 1st. Anytime you multiply the same bases, you add the exponents, 8 plus 1. There's also an h exponent or an h variable raised to the 10th exponent. You cannot add 10 to a plus 1 because one's g and one is h. So this one will simply be negative 60 g to the 9th, h to the 10th. Number 17 says 5n squared to the 4th. Anytime a power is being raised to a power, this is the instance where you multiply. 4 is going to raise, 5 is being raised to the 4th power. And n squared is being raised to the 4th power, which means 2 times 4. 5 to the 4th power means 5 times itself 4 times. 5 times 5 is 25, times 5 is 125, times 5 more is 625. N to the 2 times 4 is 8, n to the 8th. 8 to the 9th over 8 to the 10th. When you multiply the same bases, you add. But in this case, when you divide the same bases, you subtract. So you have a to the 9 minus 10, which gives you a to the negative 1. But just like a little while ago, you can't leave a negative exponent. So we need to ride the elevator. Make it a fraction to where it can go down. And anything raised to the negative value has to go down. So 1 is left on top. A to the positive 1 comes down. There's no reason to write something to the positive 1 exponent. 1 over a. 2 to the 10th over 2 to the 12th. Same concept as number 18, except now instead of variables, you have numbers. Same base, though. They're both 2. So you have 2 to the 10 minus 12 is 2 to the negative 2, which again has to ride that elevator down. 1 over 2 to the 2nd power, it's now positive, which is 1 over 4, 1/4. J to the 9th, k to the 3rd over j to the negative 3rd, k to the 8th. Again, you're dividing, which means you're subtracting exponents. So j to the 9th minus a negative 3. Remember, anytime you have minus a negative, it means plus a positive. So j to the 9 plus 3 is j to the 12th. K to the 3 minus 8 is what you get. K to the 3 minus 8 gives you k to the negative 5. Again, you can't leave a negative exponent like k to the negative 5th. So create a fraction by putting it over 1, and only the thing that's being raised to the negative value needs to ride the elevator. So k to the negative 5th goes down. J to the 12th stays right where it is on top. K to the negative 5th goes down and becomes k to the positive 5th. J to the 12th, k to the 5th. 6k over 2 squared, 6k over 5 squared. Everything here needs to be multiplied or needs to be squared. 6 needs to be squared, so 6 squared. K needs to be squared, and 5, can't forget about that one, needs to be squared. So 6 squared means 6 times 6, which is 36, times k squared, over 5 squared, which means 5 times 5, which is 25. The only thing you would need to do at this point is if 36 and 25 shared a factor, meaning you could reduce them with one of their factors, you would do so. But since they don't, this is our simplified version: 36k squared over 25. We're solving these equations. These just getting values for x now. So x squared plus 8x plus 16 is equal to 81. In order to do this, you need to make it equal to 0. So when we move 81 over, it's positive. We need to subtract it. So when you subtract it on the right, subtract it on the left. Positive 16 and negative 81 are opposite sides. So you need to subtract them. So we need to borrow one. 11 minus 6 gives us 5. We had to borrow 1. So 7 minus 1 is 6. And since 81 was the higher absolute value, we'll keep the negative value 65. On the right-hand side, it'll say equal to 0 now. The rest of it says x squared plus 8x minus 65 is equal to 0. From here, what you need to do is you need to factor this trinomial by making it say x times x to get x squared. Remember, you're foiling it backwards. Factor your c value, which is 65. 65, your factors of 65 are 1 and 65. 2 doesn't go into it. 3 doesn't go into it. Neither does 4. 5 does. 5 goes into it 13. That's the number we're actually looking for. 5 and 13. So your factors 5 and 13 will get you to B's value 8. So 5 and 13, this tells you that the signs are different. One's positive and one's negative. This tells you that the bigger one is positive. So since 13 is bigger, it's plus 13. 5 is smaller, it's minus 5. Once it's factored, though, both of those are equal to 0. So what you need to do is take each of those and make them equal to 0. X minus 5 equals 0, and x plus 13 equals 0. So it's just one-step equations here to get x by itself. Undo minus 5 by adding 5 to both sides. So x is 5. That's one of the answers. And undo plus 13 by subtracting it on both sides. X is negative 13. Negative 3y plus 14 equals 4y plus 4. Distribute 4 times y is 4y times 4 is plus 16 is equal to negative 3y plus 14. Undo. Before you undo, what you need to do is get all of your variables on the same side. Y, since you have it on both sides, you need to bring the smaller one usually over to the larger one. Negative 3y is smaller than 4y, so bring it over. Negative 3 is like minus 3y, so undo that by adding 3y. If you do it to the left, do it to the right. 4y plus 3y is 7y. Still has plus 16. It's still equal to, this is going, 14 on the left. Since 7y is on the right, bring positive 16 over to the left side. Undo 16 by subtracting it, since it says plus. Do the same here. 14 minus 16 is negative 2, is equal to 7y. And then get y by itself by dividing by 7 on both sides. Y is equal to negative 2 over 7. Distribute 4 times y is 4y. And 4 times 2 is positive 8 is equal to 36. Undo at this point. Undo to get y by itself. That's your goal. Undo plus 8 by subtracting it on both sides. 36 minus 8. 6 minus 8, 16 minus 8, I should say, is 8. When you borrowed it, 2 minus 0 is 2. So 4y then is equal to 28. Undo 4 times something by dividing by 4 on both sides. So y's value then is 7. Factor the expression. So now this is just like we did a minute ago, except you don't have to make it equal to 0. Factor this out simply by saying x times x. Your factors of c's value, in this case 15, are 1 and 15, and 3 times 5. Which pair of those will get you to b's value 2? The only pair that'll do it is 3 and 5. Remember, this tells you the signs are different. This says since they're different, the bigger one is minus. 5 is bigger, so it's minus. 3 is smaller, so it's plus. X plus 3 times x minus 5. Number 26 says write the number in the form a plus bi. Undo the square root of negative 16 by taking the negative out by multiplying it by I. So you have the square root of 16 plus 6. And the square root of 16, or what number times itself, is 4 times I. So if we rewrite this to make it look a little bit neater, it'll be positive 6 plus or minus 4 times I. Number 27 says solve the quadratic equation by completing the square. Completing the square, you need to find a new C value because 60 is not a good one to complete the square with. So in order to move 60 over, you subtract it. When you do the left, you do the right. So what you have now is x squared plus 14x plus c is equal to 0 minus 60 is negative 60. In order to find a new c value, you need to take b's value, divide it by 2, and square it. B's value in this case is 14. So 14 divided by 2 is 7, and 7 squared is a positive 49. But remember, when you add 49 to one side, you need to do the same to the other side. We did it to the left, do it to the right. So negative 60 plus 49 is negative 11. And we now have a perfect trinomial on the left. So in order to take a perfect trinomial and separate it to do a binomial squared, you take the square root of the first term, x squared, and get x, and the square root of the third term, 49, and get 7. The sign in front of b is the one that goes between them, x plus 7, and the entire binomial is squared. Now we have x plus 7 squared is equal to negative 11. Undo squared. We want to undo to get x's value all by itself. So undo squaring the entire thing by taking the square root. When you do it to the left, you need to do it to the right. This will cancel out this and leave you simply with x plus 7. Now it's equal to the square root of a negative value. Again, just like on the last problem, in order to pull a negative from underneath the radical, we need to multiply it by an imaginary number. I times the square root of 11. In order to get x by itself, we need to undo plus 7 by subtracting it. When you do it to the left, do it to the right. We can't take it away from the square root of 11 because they're not like terms. But what we have now is x is equal to negative 7 plus or minus I times the square root of 11. 28 says to rewrite it in vertex form. In order to rewrite vertex form, you need to complete the square, just like we did on number 27. You need to bring this plus 5, this is a bad C value, over to the left by subtracting 5. When you do it to the right, do it to the left. What that leaves you with is y minus 5 is equal to x squared minus 6x plus c. We need a good c value. Again, c, take b's value, negative 6, divided by 2, and square it. Negative 6 divided by 2 is negative 3. That squared is positive 9. So that's our new C value. But remember, when you add 9 to one side, you must add it to the other side. So what this gives us is y plus 4 is equal to a perfect trinomial on the right, just like a minute ago. In order to break a perfect trinomial down, take the square root of the first term, x squared, you get x, and the square root of the last term, 9, you get 3. Again, this is the sign that goes between them, the one in front of b, x minus 3 squared. And then the only thing you have to do to make it vertex form is isolate y, get y all by itself by subtracting 4 on both sides. Remember, you can't take 4 away from inside the parentheses because they're not like terms. So y is equal to x minus 3 squared minus 4. That is vertex form. Remember what the vertex is based on that? It's the opposite of what you see in parentheses for x's value. That says negative 3, so it's positive 3. And it's exactly what it says on the outside of the parentheses, negative 4. So the vertex then would be positive 3, negative 4. 29 says use the quadratic formula to solve the equation. Quadratic formula, x is equal to negative b plus or minus the square root of 4, the square root of b squared minus 4ac, all of that over 2 times a. So what we need to do is we need to make sure our equation is in standard form. Ax squared plus bx plus c. It is. I'm sorry, I said standard form. Ax squared plus bx plus c. No, I said it right. Take all of those values and plug them in to find x's value. X is equal to negative, b's value is negative 1. So it's negative, negative 1 plus or minus the square root of b squared, again, negative 1 squared, minus 4 times a's value, again, is negative 1. So negative 1 times c's value is negative 3. All of that, again, is over 2 times a's value, which is negative 1. So let's simplify the entire thing. Negative 1 squared is 1. Negative 4 times negative 1 is positive 4. And positive 4 times negative 12, positive 4 times negative 3 is negative 12. All of that is over 2 times negative 1, which is negative 2. Outside of the radical, negative 1 times negative 1 is positive 1. So it's 1 plus or minus square root of 1 minus 12 over negative 2. So let's simplify this. Let's take away everything else we can right here. Simplify what's underneath the radical. The square root of 1 minus 12 is negative 11. So it's 1 plus or minus that over negative 2. And then in order to get rid of that negative from under that radical, just like we did a little while ago, multiply the square root of 11 times I. So we have 1 plus or minus I times the square root of 11 over negative 2. So x's value is equal to 1 plus or minus I times the square root of 11 over negative 2. That's using the quadratic formula. Solve the equation by finding square roots. You work your order of operations backwards. Please excuse my dear Aunt Sally. So the first thing we want to do is we want to undo anything that's addition, undo any addition and subtraction. We don't have that, followed by multiplication and division. We do have that. 3 times x squared, divide by 3. When you do the left, do the right. X squared is equal to 30 divided by 3, which is 10. Next thing you want to undo is any radicals or any square roots. We have x squared, so any exponents, I should say, we take the square root of it to cancel out x squared. When you do the left, you do the right. So x is equal to the square root of 10. There are no perfect factors in 10, so it's both positive and negative square root of 10. 31 says simplify this one by rationalizing the denominator. You cannot have a radical at the bottom of a fraction. In order to get rid of it, you multiply whatever that is, the square root of 15, and you do it over itself. The square root of 15 over the square root of 15. When you multiply straight across, 3 times the square root of 15 is going to be written just like that, since there's no perfect factors in 15, over the square root of 15 times the square root of 15. Remember, anytime you multiply the same radical times itself, it'll simply be whatever the radicand is, whatever's under the radical, 15. Last thing you got to do here is you can see that 3 and 15 share a factor 3. So 3 goes into itself once and into 15 5 times. So the square root of 15 over 5 is the simplified version. 32 says 3 minus the square root of 6 times 8 plus the square root of 6. FOIL, first, outer, inner, last. F, the first two terms, 3 times 8 is 24. O, the outside terms. Remember, think of it as a dartboard. This is the inside. This is the outside if you get stuck on that. The outer terms, though, 3 times the square root of 6 is positive 3 square root of 6. I, the inner terms, again, think of that dartboard, negative square root of 6 times 8 is negative 8 square root of 6. And L, since I moved over so far, are the last two terms, negative square root of 6 and positive square root of 6. A negative times a positive is a negative. The square root of 6 times the square root of 6 would give you the square root of 36, or like we said a second ago, since we're multiplying the same radical by itself, it'll simply be 6, because the square root of 36 goes back to being 6. At this point, put your like terms together. 24 and negative 6 can be combined. 24 minus 6 is going to be 18. And 3 times the square root of 6 can be put together with negative 8 times the square root of 6, since they're both multiplied by the square root of 6. 3 minus 8 is negative 5 times the square root of 6. And this is our simplified answer for 32. 18 minus 5 square root of 6.